Friends, at this very moment, a magnificent galaxy, home to approximately 1 trillion stars, is rushing towards our planet at an astonishing speed of 402,336 kilometers per hour. This colossal star system, known as Andromeda, is a true cosmic giant, surpassing all our previous notions of what is possible. Its impressive size spans 220,000 light-years across, making our own Milky Way galaxy seem modest and miniature in comparison. Today, we embark on a fascinating journey to comprehend the true scale of Andromeda, from its blazing, energetic core to its invisible yet vast dark matter halo, which, as it turns out, extends 6 times farther than we ever imagined. Our path will lead us through colossal star-forming regions, larger than entire galactic arms, past ancient globular clusters, and the long spiral arms containing countless stars. If you are ready to grasp just how truly massive our cosmic neighbor is, then prepare yourselves, for we are about to explore something unimaginable. Let this exciting journey begin. High in the night sky, a humble speck of light serves as a silent testament to a truth that has always been with us. This speck is none other than Andromeda, our closest galactic neighbor. For centuries, it remained shrouded in mystery. For decades, it was an unsolved enigma, and only recently has humanity begun to peel back the veil on its true scale. At first glance, Andromeda hardly seems remarkable. If you step outside on a dark autumn evening, away from the bright glow of city lights, you might mistake it for a tiny, inconspicuous cloud. It doesn't twinkle like distant stars, nor does it shine with the dazzling brilliance of a planet. It simply hangs there, ghostly and delicate, as if painted on the velvety darkness with a single light brushstroke. And yet, this faint smudge contains more stars than our entire Milky Way galaxy. What appears small and insignificant to the human eye is, in reality, a boundless cosmic giant. For most of human history, people had no idea what they were observing. Ancient civilizations wove Andromeda into their myths and legends, envisioning it as a divine omen, a celestial presence, or simply a fragment of mist floating in the heavens. For Greek storytellers, it became an integral part of the legend of Princess Andromeda, chained to rocks as a sacrifice and rescued by the heroic Perseus. They could not have imagined that this delicate smudge was not a star or a cloud, but a galaxy of truly unimaginable proportions. It was only with the advent of telescopes that Andromeda gradually began to reveal its many secrets. Early astronomers, observing it through glass lenses and polished mirrors, called it a nebula, a word that literally means cloud. They hypothesized that it might be an unusual cluster of gas located somewhere within our own galaxy. For them, the Milky Way represented the entire universe. The idea that there could be other, equally vast star systems millions of light-years away seemed almost inconceivable. But the truth patiently waited, carried by faint light that had traversed the abyssal void for millions of years to reach us. This light, however soft and barely perceptible it seemed, began its long journey long before humans appeared on planet Earth. When the photons that touch your eyes today first embarked on their grand voyage, the outlines of continents looked entirely different. Ice ages came and went, succeeding one another. Entire biological species evolved, flourished, and vanished forever. Throughout this profound time, light moved continuously, never slowing, never stopping, until it finally reached you in this moment of quiet reflection. When scientists finally managed to measure the distance to Andromeda, the results were truly astounding. This faint smudge was not within our galaxy at all. It was located far beyond its boundaries, representing a separate island universe. This epical discovery fundamentally changed our understanding of our own place in the universe. We could no longer consider the Milky Way to be the sole and all-encompassing entity. Instead, we found ourselves to be just one of countless galaxies drifting in a boundless ocean of billions of similar star systems. Andromeda calls us to always remember the true scale of the universe. It serves as a powerful reminder that what seems small and insignificant can, in reality, be immense, surpassing all human comprehension. It whispers to us that we are part of something much grander, something that is still unfolding and evolving. This faint speck of light in the night sky is not just an object to observe. It is a cosmic invitation, a powerful reminder that our personal story is an integral part of the larger story of the universe itself. Long before humanity invented telescopes, ancient observers of the night sky noticed a strange cloud-like glow shimmering in the constellation Andromeda. They didn't realize then that their gaze was piercing millions of light-years, reaching a galaxy significantly larger than our own. For these people, the night sky was a living chronicle filled with stories. Every shimmering point of light became a character, every barely visible smudge a profound symbol. The peoples of the Mediterranean, gazing at the pattern of stars surrounding this enigmatic glow, wove around it the myth of Andromeda, a princess chained to rocks as a sacrifice to a sea monster, but rescued by the valiant hero Perseus. The heavens served as a boundless canvas upon which myths and profound meaning were skillfully painted against the backdrop of the endless void. And while their legends could not reveal the true nature of this magnificent galaxy, they captured something truly profound. That this faint glow carried meaning, that it was something far greater than mere starlight. Imagine the feelings these ancient observers must have experienced. With no concept of galaxies, no understanding of light years, they gazed at Andromeda with profound wonder. The unaided human eye, without the help of technology, can only discern the central, brightest part of this galaxy. This concentrated glow of billions of distant suns, merged into one, must have seemed ethereal. A cloud, too stable to be a mere weather phenomenon, and too delicate to be an ordinary star. They could not know that they were actually seeing the combined light of countless worlds, where each sun was as real as our own star. For centuries, Andromeda remained shrouded in uncertainty. Ancient Chinese astronomers recorded it in their celestial maps almost 1,000 years ago, cataloging it as a cloud among the stars. Medieval Persian astronomers also mentioned it in their writings, describing its nebulous appearance, but having no understanding of its true nature. Various cultures around the world shared the same mystery. No one could know that this faint smudge they so meticulously described was not just nearby, but at an unimaginably distant remove. There is something truly humbling in this observation. When you look at Andromeda today, you join an ancient lineage of observers whose history spans the entirety of human existence. You see the same nebulous glow that shepherds once saw above deserted horizons, that sailors noticed while navigating by the stars, that storytellers wove into constellations and legends. Through the expanse of time and the diversity of cultures, the human experience of contemplating Andromeda has always been one of quiet awe. And yet, the true scale of what they saw was beyond even the wildest imagination. To call it a cloud was not entirely wrong. Andromeda does indeed contain vast clouds of gas and dust. But to recognize it as a galaxy, that colossal leap in understanding, required centuries of science, the development of instruments, and an unprecedented courage to reimagine the very structure of the universe. The ancients gave Andromeda a name and a place in their myths. We, standing on their shoulders, can now give it precise context in the grand structure of the cosmos. Even before its secrets were revealed, Andromeda was already calling to us. It was an essential part of a great puzzle, awaiting its rightful place. It seemed to whisper to every observer, "There is something more here, more than the stars you know, more than the world beneath your feet." The ancients didn't have the answers, but they had the questions, and those questions were enough to make them look up night after night, to wonder at the faint smudge in the sky. It was the first glimpse of a neighboring galaxy by ancient eyes. Andromeda is 2.5 million light-years away. Even at the speed of light, this journey takes longer than humanity itself has existed. Nevertheless, its light still crosses the abyssal void and reaches our eyes, carrying whispers from a past we can barely imagine. When we speak of a light year, it can sound deceptively simple. The distance light travels in 1 year. But light is the fastest thing in the universe. It races at 299,792 kilometers per second, so fast it can circle the Earth 7 times in a single heartbeat. Stretch that incredible speed over 12 months, and you get a unit so vast it defies our everyday sense of distance. Multiply it by 2.5 million, and you begin to glimpse the true scale of the separation between us and the magnificent Andromeda. Consider this truly immense distance. If an imaginary traveler could continuously drive a car at highway speeds without stopping for a moment's rest, their arrival at the Andromeda galaxy would not occur in centuries or even millennia, but only after 30 billion years. By then, our home planet, Earth, would have long ceased to exist. Continents would have taken on entirely new, bizarre shapes. Our sun would have swelled into a red giant, and our entire solar system would be completely unrecognizable. Even at such an incredible pace of movement, the neighboring galaxy would remain essentially unreachable. And yet, light from this distant galaxy reaches us every night. Photons that began their long journey even before our species appeared on Earth find their way through the infinite void and penetrate our atmosphere. When these tiny particles of light finally touch human eyes, they carry a message written in the very distant past. The glow we see from Andromeda tonight began its journey when the early ancestors of modern humans were not yet even formed in evolution, when long-extinct creatures ruled the world. Looking at Andromeda is not the same as observing the present moment. It is like looking through time itself. The empty space between us is almost entirely devoid of matter, but not absolutely. It is filled with sparse hydrogen atoms, extremely weak magnetic fields, and the invisible presence of mysterious dark matter. However, compared to the density of our solar system, this space is truly silent. A silence so profound that entire galaxies can drift freely within it, never touching each other. To us, this interstellar space seems frightening and vast. To Andromeda and the Milky Way, this void is only a relatively small gap to overcome in their majestic cosmic dance of galaxies. In fact, Andromeda is not moving away from us, as most other galaxies do. The expansion of the universe constantly stretches space itself, pushing distant galaxies farther apart. But Andromeda is close enough and massive enough for its gravity to overcome this expansion. Instead of receding, it is slowly but steadily approaching us. Across these 2.5 million light-years, it creeps towards us at 402,336 kilometers per hour, drawn by the same universal force that keeps Earth orbiting the Sun. The distance, though colossal, is constantly shrinking. Therefore, when you look at Andromeda, you are simultaneously seeing both the past and the future. You see light that has come from the very distant past, but you are also observing a galaxy that is steadily moving towards us, destined to change the night sky billions of years from now. This is a powerful reminder that the void is not eternal. It is a bridge stretching across space and time, connecting two galaxies that will one day become one. Within Andromeda reside nearly 1 trillion stars, significantly more than in our Milky Way. Each of these stars could potentially be home to its own worlds, its own planetary systems, its own possible stories of life. When we say Andromeda is big, we mean its inconceivable, mind-boggling scale. 1 trillion is a number that virtually escapes the human mind. We can easily imagine 12. We can stretch our imagination to 1,000. 1,000,000 seems huge, and 1,000,000,000 borders on the incomprehensible. But 1 trillion? To count to 1 trillion, naming one star every second, it would take you over 31,000 years without any rest. And yet, this staggering figure is only the very beginning of understanding Andromeda's scale. Each star is not just a tiny point of light, but a sun in itself, burning with energy, shaping the space around it, and possibly hosting an entire family of planets. Some of these stars are small, dim red dwarfs, the most common type in the galaxy. They burn slowly, incredibly efficiently consuming their nuclear fuel, and can shine for trillions of years, far longer than the universe has existed so far. Others are massive blue giants, blazing with such fierce brilliance that they live only a few million years before collapsing in powerful, catastrophic explosions. Between these extremes are stars like our Sun, stable and steady, providing light and warmth for billions of years. Imagine the incredible variety of skies on these worlds. On one planet, a dim red star might cast an eternal twilight glow, while another world might orbit a double sun, experiencing two shadows simultaneously. Still another might circle close to a blue-white giant, its days bathed in piercing light, and its nights faintly glowing from the afterglow of its fierce sun. Multiply these possibilities by 1 trillion, and you will only begin to sense the immensity and boundless grandeur of Andromeda. The multitude of stars that make up the Andromeda galaxy are remarkably ancient. This majestic galactic system itself took shape billions of years before our planet Earth formed. Some of its stellar lights were already shining in space when our solar system was just a swirling cloud of cosmic gas and dust particles. Others, however, are newborns, still in the luminous embrace of nebulae, where gas, contracting under gravity, bursts into flame. This peculiar mixture of ancient and young paints the Andromeda galaxy as a place of continuous renewal. Stars complete their life cycle, scattering heavy chemical elements into space, and then new stars are reborn from these ashes. Where there are stars, there may well be planetary systems. If even a fraction of Andromeda's stars host their own worlds, then the entire galaxy could potentially contain trillions of planets. Some are likely barren, some are unusually strange, and just possibly, some are inhabited. The sheer number of these worlds significantly tips the scales in favor of life existing somewhere out there, even if we are never destined to see it. When we describe Andromeda as big, we are not just talking about its colossal size, measured in light years. We are also describing the incredible weight of the possibilities it contains. 1 trillion stars, each representing a story waiting to be told. Some of these stories may surprisingly mirror our own. Others may prove far stranger than we can imagine. All of them together form a grand cosmic library, written in light that stretches across the night sky, reminding us that our sun, however powerful it may seem, is just one of countless others. The true size of Andromeda cannot be measured solely by its visible stars. Around it stretches a vast halo of dark matter, encompassing millions of light years. This invisible structure outweighs everything we can see combined. Dark matter remains one of the greatest mysteries of modern science. It neither emits nor reflects light. It does not absorb light waves. To our senses, it is completely transparent. And yet, its mass exceeds that of every star, every planet, every nebula, every glowing spiral galaxy we observe in our telescopes. If Andromeda's luminous disk is comparable to a lantern radiating light into the night, then its dark halo is the invisible room holding that lantern, vaster, emptier, and yet far more massive. Astronomers detected the existence of dark matter not because they saw it, but because they observed its gravitational effects. When they measured the speed at which Andromeda's stars orbit the galactic center, they encountered something unusual. Stars on the galaxy's periphery were moving too fast. The visible matter, the trillion suns, the luminous gas, the glowing arms, simply wasn't enough to hold them together gravitationally. Something else, something invisible, provided the additional gravitational pull. This invisible mass was named dark matter. And so, the true boundary of Andromeda is not the elegant spiral we see in telescopes. It is something much grander. It is a sphere of invisible mass, a halo extending 2 million light-years. Imagine that for a moment. The visible part of the galaxy might span 100,000 light-years from edge to edge, but its dark halo is 20 times larger, enveloping it in a cocoon of gravitational force. Within this halo, stars and galaxies move like leaves caught in a hidden current. Dark matter shapes their trajectories, guiding their movement even though they cannot see it. It is akin to the wind that determines the flight of birds, invisible but undeniably present. We inhabit a universe where most of the matter is hidden. where the bright galaxies we observe are merely the tips of enormous, invisible structures. This halo also connects Andromeda to the broader cosmic web. Along the invisible filaments of dark matter, galaxies cluster together, bound across distances so immense they defy human comprehension. Andromeda itself is not an isolated cosmic island. It is a node in this grand web. Its dark halo merges, overlaps, and pulls on the halo of our own Milky Way. These invisible forests ensure that in 4 billion years, the two galaxies will meet in a cosmic dance. To look at Andromeda and imagine its dark halo is to embrace a strange truth. What we see is only a fragment of reality. The stars, however dazzling, are merely the outlines of something much larger. The true mass of the galaxy is invisible, a shadowy realm of mass and gravity that eclipses the luminous disk we admire. And so, Andromeda always serves as a reminder of profound humility. What is visible to our eyes by no means exhausts the fullness of being. The universe is defined not only by dazzling light, but also by what is securely hidden beyond human sight. Its grandest structures are built not of radiance, but of silence. For many years, astronomers underestimated the true width of the Andromeda galaxy. However, the advent of new, more sophisticated telescopes, innovative methods for mapping cosmic objects, and comprehensive stellar surveys has revealed a truly shocking truth. It turns out that Andromeda's boundaries extend twice as far as we once imagined. For a long time, our understanding of Andromeda resembled looking at a majestic mountain through a thick morning fog. We discerned its general outlines, but its true, colossal scale remained hidden. The galaxy's central core shone brightly in telescope eyepieces, and its spiral arms unfurled like exquisite ribbons of starlight, captivating observers. But where exactly did this immense galaxy end? Our measuring instruments were limited in their capabilities, and our measurements remained uncertain. For this reason, Andromeda was depicted on our cosmic maps as significantly smaller than it truly deserved. The very nature of galaxies harbors a fundamental problem. Unlike planets, they lack clearly defined edges. A planet, such as our Earth, is a sphere with a distinct boundary: air above, solid ground below. However, galaxies gradually and imperceptibly dissolve into the surrounding darkness. Their stars become increasingly sparse in vast halos, and their gas disperses into boundless clouds. Their invisible influence extends far beyond visible limits due to gravity. Therefore, declaring where one galaxy ends and cosmic emptiness begins is as much a philosophical question as it is a scientific challenge. For decades, astronomers meticulously measured Andromeda's bright central regions and mistakenly assumed that these constituted the entire galaxy. However, as technology steadily improved, faint stars began to appear that were previously completely invisible to the human eye. Deep surveys revealed entire streams of stars, extending far beyond the luminous spiral arms. Some of these stellar streams turned out to be the remnants of smaller galaxies that had been absorbed by Andromeda's powerful gravity. Others were stars orbiting at unusually vast distances, still inextricably bound to the galaxy's colossal mass. Each new discovery pushed Andromeda's edge farther and farther out, forcing us to redraw the map of our cosmic neighborhood. A turning point came with the advent of wide-field telescopes, capable of imaging vast swaths of the sky simultaneously. Instead of focusing all attention on the galaxy's luminous heart, astronomers could finally trace the delicate halo of stars surrounding it. What they found was truly astonishing. Andromeda was not just 100,000 light-years across, as once believed. Its true stellar disk and extended halo stretched for almost 200,000 light-years. And if the influence of its dark matter halo is considered, the galaxy's effective boundary reached millions of light-years. This monumental discovery changed not only our perception of Andromeda, but also our own location in the boundless cosmos. The Milky Way and Andromeda turned out to be significantly closer in size than once supposed. Their halos already, in some sense, overlap. In a way, the two galaxies are already touching, their outermost stars and invisible matter intertwined. The upcoming collision is not an event that will begin only billions of years from now. It has, in fact, already started in the distant outskirts, where gravity has bound them in a slow but inevitable embrace. Every new measurement humbles us, showing the limits of our previous knowledge. Every technological advance demonstrates that the universe is significantly larger, more wondrous, and far more interconnected than we could have imagined. What was once perceived as a neat neighboring spiral galaxy has transformed into a colossal giant, whose boundaries are already touching our own galaxy. The lesson we learn from this is simple yet profound. Our maps are always incomplete. The cosmos always proves to be larger than the lines we draw around it in an attempt to describe it. Andromeda's expanding dimensions are not just numbers on a chart. They are a powerful reminder that reality itself is significantly deeper and wider than we are capable of seeing, and that every faint glow in the night sky can hide a story far grander than we dared to imagine. Long rivers of stars float around Andromeda, representing the remnants of smaller galaxies it has absorbed. These stellar streams trace its turbulent history, vividly demonstrating that galaxies grow by consuming other cosmic objects. If we could dim Andromeda's bright core and arms, the hidden truth would become absolutely clear. Faint, curved arcs of light emanate from the galaxy. These are the traces of stars, stretched to incredible thinness over millions of years of orbital motion. However, meticulous research conducted with telescopes specifically designed to capture the faintest glimpses of light reveals these ghostly cosmic streams. They are like fossils carved by starlight, silent testaments to ancient collisions and cosmic conquests. Each such stellar river tells its own unique story. Long ago, a small dwarf galaxy ventured too close to its massive neighbor, the Andromeda galaxy. Its stars, once held together by their own gravity, began to experience the significantly more powerful pull of the giant galaxy. Gradually, over many billions of years, its slender structure disintegrated. These orphan stars are no longer part of their original parent galaxy. They are now forever bound to Andromeda's gravitational field, becoming an integral part of its ever-increasing mass. This process is widely known as galactic cannibalism, and it is by no means a rare phenomenon in the universe. Galaxies grow by absorbing their smaller neighbors. The streams we observe today are the remnants of this grand process. They are thin threads pointing to places where entire galaxies once flourished. Some of these streams describe vast loops around Andromeda, while others pierce its extensive halo like arrows frozen in time. Collectively, they form a chronicle of cosmic violence and continuous transformation. It is remarkable how delicate this cosmic violence seems when viewed on galactic timescales. One such collision can last for billions of years. From our terrestrial perspective, these stellar streams appear motionless, as if frozen in place. But if we could significantly accelerate the passage of time, these elegant arcs would begin to twist and shift, wrapping around the center of the Andromeda galaxy, gradually blending with its disk until the original structures ultimately disappear completely. The result is a larger and more powerful galaxy, enriched with the stars it has absorbed. It is hypothesized that some of these stellar streams are the remnants of galaxies that were once very similar to our own dwarf satellites, the Large and Small Magellanic Clouds, orbiting the Milky Way. Just as the Andromeda galaxy has absorbed dozens of smaller systems, so has the Milky Way. In fact, the barely visible rivers of stars stretching across Andromeda's outskirts remarkably mirror the streams already detected around our own galaxy. Both giants are shaped by the same fundamental process, caught in an endless cycle of creation through destruction. These stellar rivers also serve as invaluable clues for astronomers. By tracing their curves and meticulously mapping their motion, scientists can measure the shape of the mysterious dark matter halo of the Andromeda galaxy. Stars in this context act as breadcrumbs, marking the contours of gravity itself. Therefore, when we gaze at the Andromeda galaxy and imagine these hidden streams, we see not just a static picture. We see continuous movement, a captivating history, and a predetermined destiny, all captured in fragile threads of light. They serve as a reminder that galaxies are not eternal monuments, but living, dynamic systems that grow, collide, and reshape themselves throughout endless cosmic time. At the very heart of the Andromeda galaxy lurks a monster, a black hole with a mass more than 100 million times that of our Sun. It serves as the galaxy's anchor, consuming matter and shaping the stars that orbit around it. From afar, Andromeda's core glows with a soft, concentrated brilliance. To the human eye, it appears serene, like a lantern burning steadily in the night. However, beneath this gentle glow lies one of the most extreme environments in the entire universe. The supermassive black hole at its center warps space-time itself. Its gravity is so colossal that not even light can escape once it crosses the invisible boundary known as the event horizon. And yet, this black hole is not merely a destroyer. It is also a creator of order. Without its presence, the inner stars of the Andromeda galaxy would drift chaotically. Instead, they orbit in graceful, predictable trajectories, like dancers circling an invisible conductor. The very stability of the galaxy is partly owed to this unseen anchor. Surrounding the black hole is a region of incredible turbulence. Clouds of gas spiral inward, heating up as they fall and emitting X-rays and radio waves that astronomers can detect from Earth. Sometimes the black hole slumbers, consuming only a negligible amount of matter. At other times, it awakens, devouring matter at such an astonishing rate that it spews powerful jets of energy thousands of light-years into space. These eruptions are brief on cosmic scales, but they leave noticeable scars on the galaxy, reshaping the regions around its core. Stars that dare to approach too close to this cosmic abyss are inevitably torn apart in what are known as tidal disruptions, grand cosmic catastrophes. In these terrifying events, the black hole's monstrous gravity stretches a star like pliable taffy until it disintegrates. Its remnants then inexorably spiral into the black hole's core. These rare but stunning flashes of light blaze like distant beacons, eloquently revealing the insatiable appetite of this cosmic monster. In a galaxy numbering 1 trillion stars, the black hole's hunger may seem negligible. However, over billions of years, it consumes enough matter to steadily increase its mass, thereby gradually altering the gravitational balance of all of Andromeda. The sheer scale of this central giant is truly difficult to grasp. Our home planet, like any other world in the solar system, would be completely swallowed by its abyssal shadow. Its mass is equivalent to the weight of 100 million suns, compressed into a single point. The gravitational abyss is so deep that the flow of time itself is distorted, stretching and slowing in its presence, creating an effect that defies our everyday understanding of reality. Andromeda is not unique in its possession of such a cosmic predator. Virtually every large galaxy we observe in the universe appears to harbor a supermassive black hole at its heart. The central black hole of our Milky Way galaxy, known as Sagittarius A, is itself enormous, but Andromeda's black hole significantly surpasses it in size. This serves as a vivid reminder that our closest galactic neighbor is much larger and more powerful than we once imagined. Andromeda's supermassive heart beats in complete silence, remaining invisible, yet its existence is undeniable. It is a paradox, a void that grants structure and a destroyer that maintains order. Tracing the galaxy's spiral arms outward, we must always remember that at their center lies not a shining sun, but an invisible giant, patiently shaping the destiny of the entire galaxy around it. From afar, Andromeda appears before us, revealing its graceful spiral arms. Up close, however, these arms are vast highways composed of stars, gas, and dust, winding around a galactic disk hundreds of thousands of light-years in diameter. The arms are not solid structures, as their elegant curves might suggest. Instead, they are constantly shifting patterns, regions where matter collects, compresses, and ignites with the birth of new stars. To an observer within Andromeda, These arms would not look like luminous streaks in the night sky. They would appear as densely populated regions where bright clusters of young stars shine amidst colossal clouds of gas. For a traveler drifting through them, the arms would seem not like static features, but rather like living, constantly changing rivers of light. These arms extend from the galaxy's bright core, curving in long arcs spanning hundreds of thousands of light years. They contain stellar nurseries where new suns are born, star clusters glittering with youth, and the remnants of ancient stellar explosions. These are places of both creation and destruction, where stars ignite and die, all woven into the endless cycle of galactic life. Spiral arms also act as key drivers of structural organization. As clouds of gas drift into these dense regions, gravity compresses them until nuclear fusion begins, igniting new suns that bathe the surroundings in energy. These newborn stars are often massive and hot, burning with a fierce blue-white brilliance. They live fast and die young, exploding as supernovae in just a few million years, seeding the galaxy with heavy elements, oxygen, carbon, iron, the building blocks of planets, and, ultimately, life. Thus, spiral arms are like cosmic forges, constantly shaping the chemical composition of the galaxy. However, the arms are not permanent in the way that mountains or oceans on Earth are. They are more like waves moving across a sea of stars. As matter moves through the galaxy, it slows down and compresses in certain regions, creating the illusion of a spiral shape. Stars and gas flow into these arms, linger there for a while, and then exit back into the calmer inter-arm spaces. The spiral persists not because the same stars remain there, but because the pattern endures, like traffic jams on a cosmic highway. The view from Earth of Andromeda's arms is breathtaking. Even to the naked eye, their combined light forms a faint smudge in our night sky. Through telescopes, they reveal filaments of glowing nebula, clusters of young blue stars, and dark dust lanes tracing intricate curves. Each feature hints at the colossal scale of these structures. Clouds larger than entire solar systems, clusters brighter than thousands of suns, and voids carved by ancient supernova explosions. To imagine walking through one of Andromeda's spiral arms is to mentally undertake a completely impossible journey. It would require traversing tens of thousands of light years, even if we could travel at the speed of light. And yet, the arms themselves are not rare in the universe. They represent one of the defining characteristics of spiral galaxies across the cosmos. Andromeda's arms serve as a reminder that splendor in the cosmos often arises from motion, from continuous flow, from endless cycles of creation. From afar, they may appear fragile and ephemeral, but up close, they are colossal, representing dynamic highways along which matter and energy travel. Between Andromeda's shining stars stretch vast clouds of interstellar dust. These cosmic veils conceal the galaxy's deeper mysteries, absorbing starlight and thus altering the glow we observe from planet Earth. To the human eye, the galaxy appears as a faint, barely discernible haze, but powerful telescopes reveal dark lanes artfully woven into its spiral arms. These are not empty spaces, but rather veils composed of minute dust, grains smaller than ordinary smoke particles, scattered over many light years. And while they are delicate in their individual size, their collective presence is vast enough to obscure entire regions of the galaxy. For astronomers, they represent both a challenge and an invaluable treasure. Dust alters how we perceive Andromeda. When starlight pierces these majestic clouds, it dims and takes on a reddish hue, a process known as interstellar extinction. Bright blue stars can appear faint and orange, their true luminosity hidden behind this cosmic veil. This deception created by interstellar dust once led astronomers to perceive Andromeda as less massive than it truly is. Only with infrared and radio telescopes, capable of penetrating the obscuring clouds, has humanity begun to see the galaxy in all its majestic fullness. But dust is not only an obstacle, it is also a source of creation. It is within these clouds that the seeds for the birth of new suns lie hidden. Dust particles mix with cold hydrogen gas, forming dense molecular clouds. Over millions of years, gravity gathers this material into clumps, which then collapse and ignite, transforming into newborn stars. Andromeda's veils are, in fact, cosmic nurseries, places where the next generations of light are woven from shadow. The scale of these dusty regions defies imagination. Some extend for hundreds of light years, forming intricate lanes that trace the spiral arms like brushstrokes on a gigantic canvas. Others gather into knots and filaments, faintly glowing with the reflected light of nearby stars. When observed through powerful telescopes, these structures resemble majestic cosmic sculptures, winding columns, broad arcs, and delicate, almost weightless networks. From planet Earth, dust lends Andromeda a layered beauty. In visible light, the galaxy appears mottled with luminous streaks interrupted by dark patches. In the infrared, these same dark regions begin to glow, warmed by the faint luminescence of starlight trapped within. To study Andromeda is to explore it through many different windows. Each wavelength peels back a new layer of the veil, revealing a different, previously unseen face of the galaxy. These dust veils are not a unique feature of Andromeda. The Milky Way is also permeated by similar clouds, visible as large dark rifts in our own night sky. However, in Andromeda, these veils are particularly striking because we observe them from the outside, spread across the canvas of a spiral galaxy that is tilted almost edge-on to us. They serve as a reminder that what appears as darkness in the vast cosmos is often the birthplace of new light. So, when we gaze into Andromeda and notice the shadows interrupting its spiral glow, we are not seeing emptiness. We are seeing potential. We are seeing the raw material for star formation, the quiet architecture of creation hidden behind the dust veils. These veils conceal, but they also promise that at the heart of every dark cloud, new suns await their birth. In Andromeda's arms, massive molecular clouds collapse under their own gravity. Here, stars are born by the thousands, igniting like cosmic candles within dark nebulae. To the human eye, these regions appear as shadowy voids, blocking the light of stars beyond. But in reality, they teem with activity. Hidden in the darkness are cocoons of gas and dust, denser than the surrounding space, slowly accumulating mass. Over time, gravity pulls the material inward, compressing it tighter and tighter until pressure and temperature rise to extraordinary levels. When the core heats sufficiently, nuclear fusion ignites and a new star is born. This process is not instantaneous. It takes millions of years for a cloud to collapse and ignite. Only infrared telescopes can capture their faint warmth. As a newborn star gains power, it pushes away the surrounding material with its mighty stellar winds. The veil lifts and a young sun appears, illuminating the cosmic night with its radiance for the first time. If this process is multiplied across Andromeda's spiral arms, it becomes clear that not individual stars are being born, but thousands of stars. Entire clusters flare up like strings of lights hung across the galaxy. The most massive of these newly emerged stars blaze incredibly brightly, bathing the surroundings in ultraviolet radiation. They sculpt the nebulae around them into dramatic, spectacular forms. Towering pillars, broad arcs, and luminous walls of ionized gas. Some regions sparkle as open clusters, where dozens or hundreds of young stars shine in unison, still bound to their parent cloud. Others rapidly disperse, their components scattering under the influence of gravity, destined to wander the galaxy in complete solitude. However, stellar nurseries are not only cradles of creation, they are also arenas of destruction. The most massive stars live fast and die young, exploding as supernovae in just a few million years. These powerful explosions generate shock waves that rip through the surrounding gas, destroying some gas clouds and compressing others, thereby initiating the next cycle of star formation. This is how the galaxy is renewed. One generation of stars gives rise to the next in an endless cycle of birth, death, and rebirth. For astronomers, these stellar nurseries serve as windows into our own past. Our Sun also emerged from a similar cloud approximately 4 billion years ago, likely surrounded by thousands of sibling stars. Today, these stellar siblings are scattered throughout the Milky Way, too far away to be identified. But by observing Andromeda's stellar nurseries, we see the environment in which our solar system once formed. We see the origins of the elements that make up our world: carbon, oxygen, iron, all forged in earlier stars, then reprocessed into clouds and condensed into new suns and planets. From afar, Andromeda's stellar nurseries appear as luminous patches in its spiral arms. Up close, they are worlds of drama and transformation, where light battles shadow and where the foundations of future galaxies are laid. They remind us that even in the cold and silence of interstellar space, creation does not cease. And somewhere deep within one of Andromeda's hidden clouds, new stars faintly shimmer, igniting at this very moment. These are tiny lights against the boundless night. Not all of Andromeda radiates the glow of youth. Ancient red stars still burn dimly in the galaxy's core, survivors from the earliest epochs of cosmic history. These stars are relics, significantly older than Earth, older even than the Milky Way in its current form. Some have shone for over 10 billion years, born when the universe was still young and its galaxies were just beginning to form. They are the silent elders of Andromeda, emitting a faint, steady light, reminders of a time when heavy elements were scarce and the cosmos was much simpler. Unlike the hot blue giants that blaze fiercely and fade in a few million years, these red stars boast incredible longevity. They are small, economical, and remarkably stable. Their nuclear furnaces burn slowly, consuming fuel so efficiently that they will outlive even the current universe. Long after brighter stars have extinguished, these ancient dwarfs will still be glowing, like tiny embers in the galactic night. In Andromeda's crowded core, billions of these old stars gather together, forming a dense reddish bulge. Through telescopes, this region appears warm and golden compared to the bluer outer arms. The color serves as an important clue. Blue stars are short-lived, so any area of a galaxy dominated by red stars is a place where star formation has slowed, leaving behind only the survivors of earlier epochs. These are the keepers of Andromeda's memory. Each ancient star is a kind of time capsule. Their atmospheres preserve records of the early universe. By studying the chemical fingerprints of their light, astronomers can piece together a picture of how galaxies like Andromeda formed. Many of these stars contain only the simplest elements, hydrogen and helium. With traces of heavier atoms, forged in the first generations of supernovae, they bear witness to a time before Earth-like planets could form, before carbon and oxygen were abundant enough to spark life. These old stars also serve as cosmic anchors. Their long lives allow scientists to trace Andromeda's growth history. Some belong to populations that formed when the galaxy was young. Others were captured from smaller galaxies that merged with Andromeda, their paths preserved in long orbital loops. By following these stars, astronomers can reconstruct the history of past collisions and cosmic migrations. Imagine the fascinating drift occurring deep within the central bulge of the Andromeda galaxy. The sky there would not flash with the dazzling brilliance of a few brightest stars, but would be bathed in the light of countless dim stars, located extraordinarily close to each other. While for an Earth observer, the closest star beyond the solar system is 4 light-years away. In this region, the nearest stars could be merely fractions of a light-year apart. Night would never plunge into absolute darkness. The heavens would glow with a continuous, like eternal twilight, light, powered by the combined radiance of billions of ancient suns. In these venerable stars, Andromeda reveals its continuity, demonstrating a wondrous connection across time. It also represents a region of exceptional endurance, where stars can exist for almost the entire history of the cosmos itself. When we gaze at the reddish glow of Andromeda's core, we see not just light, but an echo of memory, still burning through the boundless void of time. Hundreds of globular clusters gracefully orbit Andromeda. dense, spherical formations consisting of ancient stars. Each of these clusters is like a precious fossil, carefully preserving the history of the galaxy's earliest days. These clusters are among the most beautiful and enigmatic structures in the entire universe. Imagine a sphere filled with stars, but not freely scattered as in our local patch of sky, but packed so densely that thousands of stars could fit into an area only a few tens of light years across. At the very core of such a globular cluster, the night would blaze with hundreds of suns, so bright and numerous that true darkness would never fall. For hypothetical planets in such regions, the heavens would be an eternal jewel box, dazzlingly bright with countless lights. Globular clusters possess incredible, transcendent antiquity. Most of them formed over 10 billion years ago, shortly after the universe itself emerged from the Big Bang. This means that many of the stars within them are almost as old as time itself. They emit a relatively faint glow, predominantly as red giants and dwarfs. Their more massive counterparts have long since completed their life cycles, transforming into supernovae. Each such cluster is like a living museum, carefully preserving the unique conditions of the early cosmos. The Andromeda galaxy contains significantly more of these guardians than the Milky Way, numbering at least 500, and possibly many more, scattered throughout its vast halo. Some orbit close to the galactic center, while others wander far out in the outskirts, tens of thousands of light-years from the core. They move like satellites, tracing elegant paths through the galaxy's gravitational field, constant companions to the larger spiral they surround. Astronomers study these clusters with reverence as they hold the secrets of Andromeda's formation. The stars within them often contain very few heavy elements, strongly suggesting their birth before galaxies underwent many cycles of star formation and death. By comparing the chemical signatures and orbits of different clusters, scientists can reconstruct when and how Andromeda grew and evolved. Some clusters appear to be native, formed directly within Andromeda itself. Others may have been immigrants, brought in by smaller galaxies that Andromeda absorbed, leaving their stellar spheres as relics of long-vanished systems. The sheer endurance of these clusters is astounding. While a galaxy's spiral arms shift and dissolve over billions of years, globular clusters persist, tightly bound by gravity. Their stars are like members of a single family, inextricably linked forever, resisting the pull of galactic tides. Even when galaxies collide and merge, these clusters often survive the chaos, moving into the next epoch of cosmic evolution. From Earth, we see them only as faint points near Andromeda's disk, invisible to the naked eye, but revealing themselves in full detail through powerful telescopes. Up close, their beauty could rival all other splendor in the galaxy. Dense swarms of ancient suns sparkling in a perfect sphere. Each star separated by distances still vast, but unimaginably closer than in our own relatively calm neighborhood. Globular clusters remind us that not all of Andromeda's history is written in gas and dust, in the fleeting brilliance of young stars. Some of it is written in longevity, in stability, in the quiet persistence of stellar families that have survived almost the entire history of the universe. They are the guardians not only of Andromeda's past, but also of its future. They are witnesses that will remain long after new generations of stars come and go. Beyond the visible spiral lies a faint halo of stars, lonely suns drifting far from the core. They are pulled by the gravity of dark matter into orbits that span millions of years. To most observers, Andromeda appears as a bright disk, a concentrated vortex of starlight framed by slender arms. But this luminous structure is merely the pulsating heart of a great galaxy. Around it, stretching into the boundless cosmic darkness, lies a diffuse halo, an almost invisible sphere of stars scattered like sparks carried by a powerful wind. These stars are not part of the bustling spiral. They wander slowly over vast distances, bound by Andromeda's irresistible gravity, yet isolated from its dazzling core. The halo is striking in its scale. It can extend almost 2 million light-years from Andromeda's center, completely eclipsing the bright disk that humanity observes in its telescopes. Within it, stars move unhurriedly, tracing orbits that take hundreds of millions of years to complete. To imagine such a journey is to envision a life lived through entire epochs. Civilizations arise and vanish without a trace. Planets form and are destroyed, while one halo star completes only a small part of its grand journey around the galaxy. Many of these stars are ancient. They were born in much smaller galaxies that Andromeda absorbed in the distant past. Their orbits have gradually stretched and distorted until they became an integral part of this vast halo. In this sense, the halo is both a giant graveyard and a unique museum. It is a place where the ghosts of galaxies past still drift slowly. Each faint point of light is a relic, a surprising survivor of cosmic violence, still carrying the story of its origin in its unique chemical composition. The density of stars here is extremely low, much lower than in the dense spiral arms. A halo star can be separated from its nearest neighbor by hundreds of light years, floating in proud solitude through the abyssal void. If a planet orbited such a star, its night sky would not blaze with countless lights as it does in Andromeda's crowded core. Instead, it would seem almost empty, a dark sky with perhaps one or two faint suns in the distance. A truly lonely perspective on a vast galaxy. Astronomers meticulously study these halo stars, for they hold the keys to understanding Andromeda's growth and evolution. By mapping their movements, scientists can trace the shape of the galaxy's dark matter halo, the invisible structure that guides their complex path. Streams of halo stars often reveal the remnants of entire galaxies, stretched to thinness by Andromeda's powerful pull. The halo, though faint, is one of the best records of the galaxy's long and extremely complex history. From afar, Andromeda's halo would appear ghostly, almost transparent, like a whisper of light around a brighter center. But it is real and immense, containing not only stars, but also globular clusters, dwarf galaxies, and the invisible mass of dark matter itself. It is the unseen body around the galaxy's luminous face. The ghostly halo reminds us that galaxies are not defined solely by their brightest and most obvious features. Much of their true size and content lies in the faint, hidden, quiet. Andromeda's halo is a silent ocean of stars, stretching far beyond visibility, an invisible reminder of the powerful forces that shape every galaxy in the universe. Andromeda is not alone in its grandeur. Over 30 tiny dwarf galaxies orbit around it. Each is a loyal companion. Each is a key to understanding how great galaxies build themselves from smaller components. To visualize these companions, imagine a swarm of fireflies circling a powerful lantern. The lantern, bright and steady, is Andromeda itself. And the fireflies are small, fragile galaxies drawn into its gravitational embrace. Some are close, tightly hugging Andromeda's halo. Others drift much farther, being wandering satellites that still feel its pull for hundreds of thousands of light years. These dwarf galaxies are much smaller than Andromeda, containing only a few million stars, sometimes even fewer. Some are no more than loose swarms, irregularly shaped, their structures distorted by Andromeda's stronger gravity. Others are more compact, appearing in a telescope as faint, round smudges of light. Compared to the trillion suns in Andromeda's core, their populations are tiny. And yet, each is a living laboratory of galactic evolution. Many of these satellites bear the scars of Andromeda's hunger. As they orbit, tidal forces stretch them thin, tearing stars from their edges. In time, some will be completely absorbed, their stars ripped away to join Andromeda's halo or spiral arms. This process of galactic cannibalism is how giants like Andromeda grow. Each absorbed satellite adds mass, changes its shape, and leaves behind faint traces of starlight, stellar streams that crisscross its outer halo. Dwarf satellites also tell a story of diversity. Some of these celestial bodies are literally teeming with gas, within whose faint clouds the process of new star formation is still ongoing. Others, in contrast, are barren prehistoric systems, composed of old red stars that have long since passed their prime. Some make their way along loosely arranged inclined trajectories, while others move in eerie alignment, as if participants in a coordinated cosmic ballet. Astronomers still engage in lively discussions about why certain groups of dwarf galaxies cluster together or possess similar orbital planes. These observed patterns may serve as indicators of the influence of larger forces, possibly representing residual phenomena from one colossal collision that occurred in deep antiquity. Among Andromeda's satellites are several well-known names. M32 and M110 are two of the brightest dwarf satellites, visible even with small amateur telescopes. The M32 galaxy is a compact elliptical formation, possessing extraordinary density, as if its outer layers were long ago stripped away by Andromeda's gravitational influence. M110, on the other hand, is larger and more diffuse, showing clear signs of ongoing tidal disruption. Each of these satellites provides a unique glimpse into Andromeda's appetite, its powerful gravity that has shaped and reshaped its neighbors over billions of years. For the scientific community, dwarf galaxies are not just curious objects of study. They serve as fundamental building blocks of the universe. It is hypothesized that the first galaxies in the cosmos may have resembled modern dwarfs, small, fragile, and numerous. Over time, they gradually merged and combined, forming the spiral and elliptical galaxies we observe today. Studying Andromeda's satellites allows for a kind of journey back in time, to see the primordial material from which cosmic giants were formed. From Earth, these satellites appear faint, often invisible without the use of powerful astronomical instruments. However, together they form a majestic retinue, serving as a living reminder that even the largest galaxies do not exist in isolation. Andromeda's dwarf galaxies act as witnesses, faithful companions, and ultimately victims. Small galaxies are inevitably drawn into the history of a larger entity. Andromeda has feasted for billions of years. It has mercilessly torn apart neighboring galaxies, scattering their stars into its vast halo, leaving behind ghostly traces that stretch across intergalactic space. This process may seem brutal, and indeed it is. However, it unfolds so slowly over such colossal timescales that when viewed from afar, it appears almost serene. To the human eye, the arcs of stolen stars appear as delicate brushstrokes across the galaxy's body. These are shimmering threads of light, tracing the invisible pull of gravity. These streams are the remnants of entire galaxies, stretched to such a degree of thinness that their original forms completely disappear. Their stars ultimately become part of Andromeda's ever-increasing mass. Galactic cannibalism is one of the primary drivers of cosmic evolution. Large galaxies like Andromeda did not emerge instantaneously. Instead, they grew over billions of years, absorbing smaller systems. Every dwarf galaxy that approached too closely was captured, torn apart, and assimilated. The stars, planets, and gas within them became fuel for Andromeda's expansion. Over time, this slow accumulation transformed it from a modest spiral galaxy into one of the largest galaxies in the local group. Evidence of these feasts is literally written on Andromeda's outskirts. Observations made in wide-field surveys show faint stellar streams that wrap around the galaxy in broad arcs. Some form loops encircling the halo, like long-forgotten rings. Others cut through space in long ribbons, still tracing the paths of doomed galaxies to which they once belonged. Each of these streams is a kind of scar, a record of Andromeda's continuous appetite. Among the most striking examples is the gigantic stellar stream, an enormous ribbon of stars stretching over 100,000 light-years. This is the remnant of a galaxy that collided with Andromeda relatively recently in cosmic terms, perhaps only a few billion years ago. Today, its stars are scattered throughout the halo. Their original home has been erased from the face of space, their identity absorbed by something significantly larger. This stream serves as a vivid reminder that galaxies are not static structures, but living, constantly changing systems built from countless mergers. This cosmic cannibalism is not limited to simply increasing Andromeda's size. It dramatically reshapes the galaxy's very architecture. When a smaller star system collides with Andromeda, intense mixing of stars occurs within, leading to a thickening of the galactic disk. Such events can even trigger bursts of new star formation as gas clouds compress under gravitational forces. The galaxy that emerges from such a merger is never the same. It becomes larger, more massive, and bears the imprints of its cosmic feasts. The Milky Way, our own galaxy, is also no stranger to this process. Even now, our galaxy is absorbing the Sagittarius dwarf galaxy, whose stars form elongated tidal tails visible in our sky. And one day, in the distant future, the culminating act of galactic cannibalism will occur. Andromeda and the Milky Way will absorb each other, merging into a single colossal galaxy. So, while the term cannibalism may sound destructive, it is also a powerful creative process. From the ruins of smaller galaxies, grander cosmic structures are born. Andromeda stands as a majestic monument to this phenomenon, a sprawling spiral that was built from the lives of countless other star systems. Its vast halo is populated by the ghostly traces of their past existences. Astronomers were once puzzled as to why Andromeda seemed to contain more old stars than theoretical models predicted. Research has convincingly revealed a turbulent history of collisions and mergers, during which star formation rates rose and fell like ocean tides. Initially, the mystery seemed simple. Galaxies like Andromeda, with their wide spiral arms and rich gas clouds, should have been actively forming young stars. Andromeda does indeed have stellar nurseries, glowing with blue giants and clusters of newborn suns. However, when astronomers conducted more detailed observations, they discovered something unusual. Compared to the Milky Way, Andromeda appeared to contain a higher proportion of old, redder stars. The balance was off, as if an entire generation of stars had been skipped. This imbalance was dubbed the stellar population crisis. Why did Andromeda have so many ancient stars and fewer young ones than theory predicted? The answer lay not in the peaceful present, but in Andromeda's turbulent and dynamic past. Its history was punctuated by numerous collisions, some relatively gentle, others truly catastrophic. When Andromeda collided with smaller galaxies, vast waves of gas compressed, triggering powerful bursts of star formation. For a time, the galaxy blazed with new light. However, after such turbulent periods, the gas supply often became depleted, leading to long periods of quiescence when very few stars were born. By studying the ages of Andromeda's stars, scientists were able to reconstruct this rhythmic cycle. Millions of stars were born in a cosmic firestorm, illuminating the galaxy with their bright light. But once that gas was exhausted, the rate of new star births plummeted, leaving behind a population dominated by older, surviving stars. Today, we observe the echoes of these cycles in the diverse mix of stars. The galaxy is still forming new stars, but not with the fierce intensity that characterized its past. The abundance of old stars gives Andromeda a more subdued glow, especially in its core, where ancient red giants dominate. It's as if we're seeing the galaxy in its middle age, still active, but with the memory of its turbulent youth etched into its stars. For astronomers, this discovery was more than just a scientific curiosity. It was a reminder that galaxies are dynamic, living systems. They can flare with creation and then quiet down. Their history is shaped by chance encounters and grand cosmic events. Andromeda's population crisis powerfully tells us that even giants are vulnerable to the whims of their environment. The Milky Way also has its own rhythms. Our galaxy is currently in a relatively quiet phase of star formation. However, in the future, collisions with smaller satellites, and eventually with Andromeda itself, will trigger new bursts of activity. The crisis in Andromeda is not a failure, but a natural stage in the galaxy's life cycle. When we look at Andromeda today, we see a galaxy not frozen in perfection, but in a state of constant transition. Its stars are unevenly distributed in time. They appear in waves, in generations. Each is a reflection of past collisions and grand cosmic events. The stellar population crisis is not a flaw, it is a story written in the age of stars, a story that powerfully tells us that galaxies are alive with change. Throughout the Andromeda galaxy, dying stars explode into magnificent supernovae. Each such explosion briefly outshines the galaxy itself, generously seeding cosmic space with heavy chemical elements that subsequently form future planets. Supernovae represent the grand finales of stellar life, spectacular detonations that occur when a star completely exhausts its fuel. In Andromeda, with approximately 1 trillion suns, such events are not uncommon. Somewhere in its spiral arms at any given moment, a massive star is approaching its last breath, preparing for a cosmic fireworks display that will forever change its surroundings. For a short time, one exploding star can shine brighter than the combined light of billions of its neighbors. For anyone observing this phenomenon from a nearby world, it would appear as a sudden second sun, unexpectedly rising in their heavens. The glow would last for weeks and sometimes months before fading back into darkness. Nevertheless, the legacy of this explosion would remain forever. Supernovae are not just spectacles, they are creators. In the heart of a massive star, lighter elements are formed through nuclear fusion. Hydrogen transforms into helium, helium into carbon, oxygen, and so on. However, the heaviest elements, such as iron, gold, and uranium, are forged exclusively in the furious violence of a supernova. When a star tears itself apart, these precious elements are ejected into space, mixing with interstellar gas. Over time, they become the raw material for the formation of new stars, new planets, and perhaps new life. Every atom of calcium in your bones, every atom of iron in your blood, was once created in such a cataclysm. The statement that we are made of stardust is not poetic exaggeration, it is a scientifically proven truth. And in Andromeda, as in the Milky Way, supernovae ensure the continuation of the cycle, so that the galaxy remains enriched with the building blocks for worlds. Some of these explosions leave behind dense remnants. Neutron stars are collapsed cores of massive suns, where matter is compressed so densely that a teaspoon of such substance would weigh billions of tons. Others give rise to black holes, silent predators that lurk invisibly, their gravity trapping anything that comes too close. Thus, each supernova alters the landscape of the galaxy, creating both destruction and new opportunities. The Andromeda galaxy has given us one of the most famous supernovae in the history of astronomical observations. In 1885, astronomers recorded a sudden increase in brightness in the galaxy, a point of light so intense that it rivaled its very core. This was supernova 1885A, the first ever detected outside the Milky Way. For 19th century astronomers, it was a true revelation, compelling evidence that the universe is filled with distant explosions far grander than anything in our own sky. Although Andromeda is millions of light-years away from us, its cosmic fireworks still reach us, their light traversing the boundless void to tell a story of death and rebirth. When we observe these distant detonations, we are not only studying the fate of stars, but also glimpsing the future of our own galaxy. One day, massive stars in the Milky Way will end their journey in the same way, seeding our corner of the cosmos with the ingredients for worlds yet to be born. Supernovae remind us that ends in the universe are never absolute. They are beginnings disguised. In every flash of destruction, there is renewal. And in every spark of light scattered into the darkness lies the promise of life yet to come. Beyond its central giant, Andromeda contains a multitude of smaller black holes scattered throughout its disk. These are the silent remnants of massive stars, invisible yet extremely powerful. Each of these stellar mass black holes began its life as a massive star, tens of times the size of our Sun. When their nuclear fuel ran out, their cores collapsed under gravity, compressing matter to a point so dense that nothing, not even light, could escape. The star's outer layers were shed in a final supernova, leaving behind only an invisible remnant. What remains is a gravitational well, dark and silent, marking the graves of suns that once burned fiercely. In the vast expanses of the Andromeda galaxy, home to nearly 1 trillion stellar lights, such cosmic events have occurred countless times. Astronomers hypothesize that this colossal galaxy may contain millions of such relatively small black holes, scattered throughout its spiral arms, hidden in dense star clusters, or silently drifting in its vast halo. Their direct detection appears almost impossible, as they themselves emit no light. Instead, their invisible presence is revealed only when they interact with their surrounding environment. When a star approaches them too closely, or when gas begins to rapidly fall inward, heating up and glowing brightly in the X-ray spectrum, before disappearing without a trace into the impenetrable darkness. Some of Andromeda's black holes reside in pairs, forever bound in an orbital dance with a companion star. These unique systems are known as X-ray binaries. When a black hole begins to draw matter from its stellar partner, the gas forms a luminous disk around the invisible object, radiating energy as it spirals inward. Thanks to these specific signals, astronomers are able to track the existence of black holes scattered throughout Andromeda's disk. Each is a hidden predator, silently feeding in the night. Others drift in complete solitude, like silent wanderers who may never reveal their presence. If one of these invisible wanderers were to pass our solar system, we would not see it, but we would undoubtedly feel its influence, as its powerful gravity would distort the orbits of planets and asteroids. In Andromeda, such wanderers are like ghosts, subtly affecting the environment, but leaving no visible trace. The most intriguing possibility is that some of Andromeda's black holes are larger than stellar remnants, but smaller than the central supermassive giant. These objects, known as intermediate mass black holes, may be hidden in star clusters or in dwarf galaxies that have been absorbed by Andromeda. Their actual existence is still a subject of lively debate in the scientific community. But if they do exist, they may act as stepping stones, seeds from which supermassive black holes later grow. Taken all together, these black holes form an invisible population that is as integral to the galaxy as its bright, shining stars. They serve as a reminder that Andromeda is not only a center of light and creation, but also a realm of shadow and conclusion. The galaxy's balance depends on the harmonious existence of both these beginnings. The shining stars that generously emit light, and the dark remnants that silently await their turn among them. From our planet Earth, we see only Andromeda's dazzling face, its graceful spirals, its cosmic dust, its brightly shining core. However, hidden within this unearthly beauty are countless black holes, our galactic neighbors, whom we are never destined to meet, shaping their environment in complete silence. They remind us that the universe is not defined solely by what is visible to our sight. Much of its history is hidden in the invisible, in forces that only whisper, not shout, in power shrouded in impenetrable darkness. For many years, we held the view that the Milky Way and Andromeda were comparable in size. However, we now know for certain that Andromeda is significantly wider, more massive, and more sprawling. Nevertheless, these two galaxies are still destined to merge into a single entity. For most of the 20th century, astronomers believed that our home galaxy might well rival Andromeda in scale. Both appeared as grand spirals, each numbering hundreds of billions of stars, each possessing sprawling arms and a distinct central bulge. The Milky Way, hidden from our view by its own dust and gas, was extremely difficult to measure with sufficient accuracy. Andromeda, visible from the outside, seemed only slightly larger. But as our measuring instruments steadily improved, a clearer picture emerged, and with it came the realization that Andromeda's true size surpassed all our previous notions. The Milky Way is enormous, approximately 100,000 light-years in diameter, and it may contain between 300 and 400 billion stars. However, Andromeda extends even further. Its visible disk is more than 200,000 light-years in diameter, and contains nearly 1 trillion stars. Its mass is also significantly greater, and this is due not only to the stars we can observe, but also to its colossal dark matter halo, which envelops it like an invisible shell. Thus, Andromeda is not only wider but also significantly heavier, substantially surpassing the Milky Way in mass. This difference in size and mass is not so much a manifestation of rivalry as it is a reflection of cosmic diversity. Galaxies exist in a wide variety of forms. Some are dwarfs, numbering only a few million stars, while others are true giants, containing trillions of stellar lights. Andromeda and the Milky Way are both among the largest galaxies in our local group. However, Andromeda is undoubtedly the heavyweight. Its arms are wider, its central black hole is significantly more massive, and its population of star clusters and satellite galaxies is much richer. And yet, despite the colossal scale, size itself does not diminish significance. From within the Milky Way, our galaxy appears to us as a boundless space. Its majestic spiral arms, stretching for many thousands of light years, have more than enough room to accommodate countless worlds like our own. The fact that the Andromeda galaxy surpasses ours in size merely serves as a reminder that there is always something more, something extending beyond our immediate perception. The scale of the universe is like an infinite staircase, where each subsequent step opens up an ever wider and more breathtaking perspective. The comparison of these two galaxies also offers a glimpse into the distant future. Their vast halos have already begun to overlap, steadily drawing each other across the boundless cosmic void. The gravitational force inexorably pulls them closer, and in approximately 4 billion years, they will inevitably meet. At this critical moment, Andromeda's immense mass will play a decisive role in determining the ultimate outcome of their interaction. It is quite possible that the Milky Way will spiral into its gravitational embrace, its stars being pushed into entirely new orbits as the two galaxies merge into a single, colossal cosmic system. Some scientists have already proposed a name for this future: unified galaxy, Milkomeda, symbolizing a union that will be incomparably larger and brighter than either of them individually. So, although the Andromeda galaxy surpasses the Milky Way in both size and mass, these two cosmic systems are not rivals, but rather partners in a grand cosmic dance. Their destinies are inextricably linked, their histories tightly intertwined. To compare them is not to delve into rivalry, but rather to glimpse a predetermined fate. When we gaze at Andromeda and acknowledge its grandeur, we do not diminish ourselves in the slightest. We are merely reminded that our galaxy, too, is part of something far larger. That even the enormous Milky Way is just one fragment of a story that continues to unfold among the stars. In 4 billion years, Andromeda and the Milky Way will meet not in a furious collision, but in a slow and majestic intertwining of stars that will continue for hundreds of millions of years. To imagine this impending event is to envision two colossal oceans of light slowly drifting towards each other through the silent void. Each galaxy is truly immense, yet so diffuse that when they finally overlap, the stars themselves will almost never collide. Instead, they will pass by each other, like dancers in a complex and graceful waltz. Their paths will change, their orbits will reconfigure, but their individual identities will remain intact. It is gravity, not direct impact, that will weave them into one. First, the galaxies will approach cautiously, like partners circling on a vast stage. Their outer halos are already touching. Barely perceptible filaments of dark matter and scattered stars merge invisibly. As they draw closer, tidal forces will begin to distort their elegant spiral structures. Long tails of stars will stretch outward, flung into space like ribbons pulled by unseen hands. From afar, it will appear as if the galaxies are reaching for each other, their forms unraveling as they embrace. For hundreds of millions of years, this slow-motion cosmic dance will continue. Andromeda will pass through the Milky Way, glide past, and then be drawn back again. Their mutual gravity will ensure multiple encounters. Each pass will stir the stars, triggering bursts of new star formation as gas clouds collide and compress. For a time, both galaxies will shine brighter than ever before, their spiral arms illuminated by newborn star clusters. From Earth's perspective, if our planet still exists by then, the night sky will be transformed beyond recognition. Andromeda, now a barely discernible faint smudge, will grow until it dominates the heavens, filling the horizon with majestic spirals of light. As the galaxies overlap, the view would be truly unearthly. Arcs of stars stretching across the sky, luminous clouds of gas igniting into brilliant nebulae. It would be a grand cosmic spectacle, unfolding not over days or years, but across entire epochs. Despite the grandeur of this event, the solar system may remain relatively unscathed. The probability of another star passing close enough to significantly disrupt our sun's stability is infinitesimally small. Nevertheless, the orbits of the planets could shift, and our system might be flung into an entirely new position within the merged galaxy. Some stars might even be completely ejected, cast into the boundless void between galaxies, doomed to drift forever in utter darkness. Ultimately, after countless passes and unhurried inward spirals, the Andromeda and Milky Way galaxies will merge into a single, much larger structure. It will no longer be graceful spirals, but will transform into an enormous elliptical galaxy, which will be smoother, rounder, and brighter than either of them individually. Astronomers have already given this new formation the name Milkomeda. Although this monumental event is relegated to the distant future, its inevitability is beyond doubt. It is recorded in the mathematical calculations of celestial body movements and confirmed by precise measurements of Andromeda's approach to our galaxy. That is why, when we observe this barely perceptible smudge in our night sky, we are simultaneously looking into the future, into a grand encounter that was predetermined billions of years ago. It is the slow and inexorable merging of two great star systems. When the cosmic collision is complete, the two galaxies will merge into a single giant elliptical system. Astronomers have named it Milkomeda, a truly cosmic union that will forever transform our night sky. This transformation will not be instantaneous, but will unfold gradually, spanning billions of years. Initially, the Milky Way and Andromeda will spiral through each other in repeated passes, like tides that ebb and flow. Each close encounter will deform their shapes, drawing long streams of stars into space and twisting their graceful spirals into astonishing and intricate configurations. By the time the merger is complete, their familiar structures will have vanished, yielding to a smooth, rounded giant, a galaxy that will be significantly larger and brighter than either of its parent systems. The resulting Milkomeda will likely take the form of an elliptical galaxy, a sprawling oval of stars, devoid of the graceful arms that once defined both spiral galaxies. Elliptical galaxies are common in the universe, especially in regions where galaxies cluster and interact actively. They possess enormous mass, contain trillions of stars, and emit light characteristic of old, redder stellar populations. Such is the fate of Andromeda and the Milky Way, to shed their spiral forms and become something entirely new. The night sky for any surviving sentient beings in this merged galaxy will be a truly spectacular sight. Where we once saw only the faint band of the Milky Way stretching across Earth's heavens, future skies will blaze with stars in all directions. Nebulae, superclusters, and arcs of starlight will appear significantly brighter and closer. The galaxy formed from this merger will be home to twice as many stars, perhaps 2 trillion in total. Each will be a tiny lantern in the boundless cosmic darkness. For worlds orbiting these suns, night will be an eternal celebration of light. However, this grand union brings not only beauty, it is also a source of renewal. Collisions between galaxies can compress vast clouds of gas, which in turn trigger powerful waves of star formation. For a time, Andromeda will glow with newborn stars, its heart blazing brighter than ever before. Thus, Andromeda's life cycle will mirror the life cycles of galaxies throughout the universe. A bright youth, a turbulent middle age, and a long, peaceful maturity. The merger will also inevitably alter the orbits of stars and planets. Some will be flung onto entirely new trajectories, spiraling closer to the central core. Others, conversely, may be ejected outward, banished into the boundless intergalactic space. Our own solar system has a chance to survive, but it may also find itself in an entirely new region of the galaxy, orbiting along paths we cannot yet predict. Astronomers find solace in the thought that this future is not as dangerous as we might initially imagine. Instead of a destructive collision, the merger is more akin to a blending, two vast clouds of light and gravity smoothly combining into one. The true drama lies not in annihilation, but in grand transformation. Andromeda will become a monumental testament to time, a symbol of the universe's boundless capacity to endlessly reshape itself. From two majestic spirals, one colossal system will emerge. It will be significantly larger, more massive, and brighter than either of them individually. And although none of us will live to see that moment, we can tonight look at Andromeda's faint glow and realize that we are gazing at the future face of our galaxy. And while stars rarely collide directly, planetary systems can certainly be thrown into chaos. Worlds may be ejected into the boundless intergalactic space, while others may find new suns to orbit. When Andromeda and the Milky Way begin their long cosmic embrace, the vast distances between individual stars will protect most of them from direct collision. However, while the stars themselves will pass safely by each other, the delicate orbits of the planets circling them may not be so fortunate. Gravity is a subtle yet powerful force, and when entire galaxies collide, it acts like a restless tide, pulling and pushing the paths of countless worlds. Let's take a closer look at our own solar system. The central star, the Sun, will continue to shine, maintaining its unwavering stability in a nuclear rhythm. However, as the gravitational influence of the Andromeda galaxy steadily intensifies, our star's orbit may undergo significant changes. There is a possibility that we will be drawn closer to the core of the newly formed galaxy. Or conversely, we may be flung outward, lost in the vast galactic halo. Planets will also feel the power of this attraction. Their orbits, which today seem so precise and stable, may be tilted or deformed. Some may even be entirely dislodged, torn from their parent star, becoming solitary wanderers in the boundless cosmic darkness. These rogue planets, ejected by the collision, will drift between galaxies, unbound to any star. Cold, lightless, and utterly alone, they will travel endlessly through the cosmic night. And yet, even these lost worlds would carry the history of their home galaxies, becoming silent witnesses to the grand merger that granted them freedom. Not all consequences of this cosmic event would be destructive. Some planetary systems might find themselves in entirely new neighborhoods, orbiting unfamiliar stars. In very rare cases, a planet might even be captured by another sun, exchanging one celestial body for another. Just imagine a world where, after billions of years of orbiting one star, its inhabitants suddenly see a new sun blazing overhead. This would be a true cosmic migration, etched into the very orbits of their home. The merger of galaxies could also trigger powerful bursts of star formation as giant gas clouds collide and compress. New suns would be born, surrounded by new planets. The future galaxy Andromeda may turn out to be richer in worlds than Andromeda or the Milky Way individually. For any civilizations that might arise or endure, the night sky of these planets would shine with more stars than ever before, the heavens transformed by this grand merger. Of course, our own planet may not survive to see this future. Long before the collision is complete, the Sun will exhaust its fuel and swell into a red giant, engulfing Mercury, Venus, and possibly Earth itself. But if humanity or its descendants survive, scattered among distant stars, they will be able to observe the merger from new homes. For them, the planetary consequences would not just be theoretical assumptions. This thought is both humbling and inspiring. Galaxies merge over billions of years, reshaping themselves with a patience that surpasses any human imagination. Planets, fragile and small, are caught in the mighty tides of this cosmic ocean. The planetary consequences of Andromeda's approach remind us that while stars may be stable, the worlds they nurture live dangerous lives, their fates intertwined with the greater story of the galaxies themselves. If life exists on planets within Andromeda, their skies must blaze with stars. From their perspective, the Milky Way would appear as a faint, ghostly neighbor in the darkness. Just imagine standing on a world orbiting one of Andromeda's trillion suns. Perhaps it circles a modest yellow star, very much like our sun. When night falls on this world, the sky explodes with dazzling brilliance. The galaxy's dense spiral arms would arc overhead, like luminous rivers of starlight, interwoven with dark lanes of cosmic dust. Star clusters would sparkle like scattered jewels. Nebulae would bloom in soft colors, and the galactic core would blaze with golden fire, far brighter than the faint band of the Milky Way we see on Earth. For any eyes looking up, the sky would never be truly dark. For such beings, the Milky Way would be a faint smudge, a soft oval of light, distant and mysterious, hanging in their sky, just as Andromeda hangs in ours. Their astronomers, if they exist, might ponder its nature. Is it a nearby cloud of stars, a strange nebula, or perhaps an entire galaxy, equal in grandeur to their own, shining across the cosmic void? Their questions would mirror ours, their wonder echoing ours across the vast chasm of space. From the perspective of hypothetical inhabitants of Andromeda, the approach of the Milky Way would also become visible. Over millions of years, this ghostly smudge, barely noticeable in their celestial sphere, would gradually increase in size and become brighter, its outlines slowly but surely transforming into a recognizable spiral shape. Many generations of extraterrestrial astronomers and night sky observers might meticulously record these changes, perhaps even predicting the inevitable collision with astonishing accuracy, long before it actually occurs. The thrilling anticipation of this grand cosmic encounter would undoubtedly become deeply ingrained in their culture, becoming an integral part of their mythology, a subject of scientific inquiry, and a source of inspiration for their collective imagination. However, beyond the macroscopic picture of the approaching galaxy, life within Andromeda would feel the immense scale of its own galaxy much more intimately and directly. In its dense central regions, where stars are unusually close to each other, the night sky of hypothetical planets would be illuminated by the radiance of hundreds of suns, creating a mesmerizing spectacle. For advanced civilizations inhabiting these crowded stellar zones, navigating the starry sky would likely be significantly easier, for their solar systems are separated by only a few light years, and their sky would be literally dotted with potential destinations for interstellar travel. Conversely, in Andromeda's vast but sparsely populated stellar halo, extraterrestrial worlds might orbit in majestic solitude, their skies appearing dark and secluded, their nearest stellar neighbors located at incredibly great distances. If intelligent life exists in these distant corners, its understanding of the universe would undoubtedly be shaped by this unique perspective. Where humanity perceives Andromeda as a distant cosmic mystery, they would likely see it as their home. And while for us, the Milky Way represents all we know of the cosmos, for them it might be just a distant puzzle, waiting to be solved. It is quite possible that their scientists, using powerful astronomical instruments, have long been aware of our existence. The faint signals of our sun, lost among a trillion other stellar lights, whisper barely audibly across the boundless void of space. This is a truly humbling thought. While we ponder their possible existence with awe, they may be pondering ours in precisely the same way. So before us stand two colossal galaxies, two fundamentally different perspectives, each gazing towards the other across countless millions of light-years of cosmic space. And within both, life, if it truly exists, may be turning its gaze to the starry sky, asking the same eternal question. Are we alone in the universe? A natural question arises. Where exactly are Andromeda's true limits? Its stellar halo gradually fades, becoming invisible to our instruments, while its dark matter halo extends significantly farther, continuing its unseen influence. In essence, this boundary is not so much a clearly defined edge as it is a smooth, gradual merging with the colossal cosmic web. When the human mind contemplates boundaries, it typically imagines clear, unambiguous lines. A coastline where the immense ocean meets solid land, or a horizon where the Earth's surface merges with the boundless sky. However, galaxies are far more complex. Their light does not end abruptly and sharply. Instead, it gradually disperses, becoming fainter and dimmer, until it finally disappears completely, giving way to absolute cosmic darkness. And even after the visible glow fades, the galaxy does not truly disappear. Its colossal influence continues to be felt in the form of gravity, inexorably drawing individual stars, vast clouds of gas and dust, and even entire satellite galaxies into its extensive sphere of attraction. For Andromeda, its visible stellar disk extends approximately 200,000 light-years, representing an elegant spiral structure, shining with the light of 1,000,000,000,000 suns. However, behind this splendor lies its stellar halo, a sparse spherical region consisting of drifting stars, ancient globular clusters, and faint streams of matter remaining from past cosmic mergers. This halo extends almost 2 million light-years, significantly exceeding the size of the luminous spiral we are accustomed to imagining. If our eyes possessed sufficient sensitivity, Andromeda would appear to us not as a faint smudge in the celestial sphere, but as a vast, diffuse glow encompassing a significant portion of the night sky. And even this vast stellar halo is not the true edge. Around Andromeda is a colossal dark matter halo, an invisible cocoon of mysterious mass that extends many millions of light-years farther. Although it cannot be seen directly, its presence is undeniable, for it shapes the movements of stars within the galaxy and warps the trajectories of satellite galaxies. In this sense, Andromeda does not possess a clearly defined, unambiguous boundary. Its colossal body gradually merges with the larger structures of the universe, overlapping with the Milky Way's own dark halo and harmoniously flowing into the filaments of the vast cosmic web. Such a merger certainly challenges our intuition and customary notions of boundaries. A profound philosophical question arises. At what point does Andromeda cease to be itself and begin to become an integral part of the local group of galaxies, or even the Virgo supercluster beyond it? The truth is that galaxies are not isolated cosmic islands at all. They are dynamic nodes in a much larger and more complex tapestry of the universe, connected by invisible threads of dark matter and constantly exchanging matter and energy with the surrounding space. Thus, the edge of a galaxy is not a specific place, but rather a gradient, a vast transitional zone where its individual identity gradually dissolves into universal cosmic interconnectedness. For modern astronomers, defining this elusive boundary is a task both practical and deeply philosophical. To accurately measure the size of a colossal galaxy, one must decide where exactly to draw the arbitrary line. At the edge of visible stars, at the outermost limits of the stellar halo, or at the absolute boundary of its gravitational influence. Each of these choices tells its own unique story, and each number obtained as a result reflects its own truth. Thus, Andromeda is simultaneously 200,000 light-years wide and millions. It is both a finite, elegant spiral and an almost infinite structure, gradually fading into boundless cosmic infinity. From Earth's perspective, this duality only adds to its charm. The faint glow visible to us represents only the brightest part of something immeasurably grander. Its true boundaries extend far beyond visual perception, beyond even the wildest imagination, gradually dissolving into the fundamental foundations of cosmic space. Thus, The question of where the Andromeda galaxy ends becomes very similar to contemplating where the limits of the universe itself extend. The answer does not lie in the existence of a clear, sharp boundary, but rather serves as a reminder that everything we see and feel is an integral part of something significantly larger, interconnected through space and time, woven into the endless, complex fabric of the cosmic web. Andromeda is not an isolated object. It is connected by invisible threads of dark matter and intergalactic gas to the other components of the local group of galaxies, being organically woven into the grand cosmic web that forms the entire universe. When astronomers study the universe on its largest scales, it no longer appears chaotic or random. On the contrary, galaxies form distinct patterns, aligning along colossal filaments that stretch, like spiderwebs, through the impenetrable darkness of space. Between these filaments lie vast voids, enormous regions almost devoid of matter, resembling bubbles in cosmic foam. Collectively, these filaments and voids form what we call the cosmic web, the fundamental architecture of the universe. The Andromeda galaxy, like our Milky Way, is located in one of these filaments. It is not a solitary traveler, aimlessly drifting in the void, but part of a vast network, a node of matter where many filaments converge. The local group, our small collection of galaxies, is one of numerous such nodes, connected to neighboring groups by invisible bridges made of dark matter. Through these bridges, gas flows and a faint but palpable gravitational pull directs galaxies into clusters, and clusters into superclusters. The cosmic web is invisible to our eyes, but quite accessible to our scientific instruments. Astronomers trace its presence by meticulously mapping the distribution of galaxies over billions of light-years. The result of these studies is a structure both fragile and colossal. Filaments, stretching for hundreds of millions of light-years, faintly glow with the light of galaxies strung along them like beads on a thread. Andromeda's place in this web is securely anchored by its dark matter halo, which in turn connects to the halos of other nearby galaxies. This interconnectedness is of immense significance. Gas flowing along the cosmic web replenishes galaxies, providing them with the necessary material for the formation of new stars. Without these cosmic supply lines, galaxies would exhaust their resources and gradually fade away. Andromeda shines today because for billions of years it has been nourished by these hidden flows. Even now, faint streams of hydrogen seep into its disk, remaining invisible to us, but vital for its continued existence. The cosmic web also dictates the fate of galaxies. The local group, which includes Andromeda, the Milky Way, and dozens of smaller satellite galaxies, is slowly drifting towards the Virgo cluster, the nearest major concentration of galaxies. In time, trillions of years in the future, these movements will bring the groups closer together, weaving them into larger and more extensive structures. What begins as a filament of galaxies will conclude with the formation of a gravitationally bound cluster, a denser node in the universal web. From a human perspective, these timescales seem incomprehensible. However, for the universe, these are natural rhythmic processes. Galaxies flow along filaments like leaves carried by a river's current, gathering where the currents converge and dispersing where the currents thin. Andromeda is one such leaf, vast beyond our comprehension, yet an integral part of something much larger. To look at Andromeda is to see not just a galaxy, but a junction point. Its light, its stars, its future merger with the Milky Way, all are shaped by the invisible web that spans the entire cosmos. The galaxy is not alone, and neither are we humans. We are part of a grand design, a universe stitched together by threads too fine to see, yet strong enough to hold all that exists. Viewed on a broader scale, Andromeda and the Milky Way are merely two galaxies within a significantly vaster structure, the Virgo supercluster, a sprawling city of galaxies bound together by gravity. From our perspective on Earth, galaxies often appear as solitary islands. We discuss the Milky Way, Andromeda, their stars and planets, as if each floats in space in complete isolation. However, when astronomers map the cosmos on its grandest scales, an entirely different truth emerges. Galaxies, like living organisms, exhibit social behavior. They form various associations, from small groups to magnificent clusters, which in turn form colossal superclusters. These superclusters are the cosmic metropolises of the universe, giant cities where galaxies appear as shining towers, and the invisible filaments of dark matter act as connecting streets. Our own cosmic home is the Virgo supercluster. Its extent exceeds 110 million light-years, and it contains thousands of galaxies scattered across its immense expanse. At its very heart lies the Virgo cluster. This dense cluster includes over 1,000 galaxies tightly bound together. The local group, which is home to the Andromeda galaxy and the Milky Way, is located on the periphery, orbiting like a suburb around a central metropolis. Despite the significant distance from the core, we remain part of this colossal gravitational family. Comprehending its true scale is almost impossible. Imagine a map where each dot represents not an individual star, but an entire galaxy. On this imaginary map, the Milky Way and Andromeda are just two tiny dots, separated by only the thinnest strip of space. Together with dozens of dwarf galaxies, they formed the local group. The local group itself, in turn, is just one of many districts on the outskirts of the vast Virgo territory. Beyond Virgo stretch other superclusters, other cosmic cities, forming an even grander structure, the observable universe itself. The supercluster unites its members through invisible filaments of dark matter. Thus, Virgo is not just a collection of galaxies, it is a cohesive system, an empire of light, stretching for hundreds of millions of light-years. For Andromeda, its location in Virgo provides a special context. It is not just a large galaxy, not just the future partner of the Milky Way, but one of thousands of citizens in a larger community. Its mass, its mergers, its halo, all are part of the same dynamics that govern galaxies throughout the supercluster. Gas streams along the filaments, flowing into the clusters. Galactic collisions trigger bursts of star formation. Groups of galaxies slowly orbit each other in gravitational dances. Andromeda's history is, in essence, a local chapter of the supercluster's grander narrative. From Earth, we cannot encompass the entire expanse of Virgo with our gaze. However, telescopes reveal its richness to us. Majestic spiral galaxies, giant ellipticals, delicate dwarfs, all are strung across the night sky in silent harmony. To look at Virgo is to clearly see our cosmic address. We do not simply reside in the Milky Way, not simply in the local group, not simply as neighbors of Andromeda. We are residents of a supercluster, one of the districts in the sprawling city of the universe. And so, when we look at Andromeda, we see not only a neighboring galaxy, but also our place in something significantly larger. The Virgo supercluster is a vast stage, and Andromeda is one of its brightest players, serving as a reminder that even cosmic giants are part of great constellations of light. Even this supercluster is just part of something even grander. Andromeda is a component of the Laniakea supercluster, a gravitational continent of galaxies stretching for hundreds of millions of light-years. The name Laniakea is Hawaiian in origin and translates as immense heaven. This is a very fitting description, for no other word can better convey the true scale of this structure. Within its boundaries are over 100,000 galaxies, each containing billions or trillions of stars. Taken together, they form a continent of light, stretching for 500 million light-years, bound not by geography, but by powerful gravity. It is an invisible force that gathers galaxies into a unified movement. Andromeda, the Milky Way, and the other members of the local group are tiny citizens of this vast realm. Our neighborhood, so enormous to us, is just one district in Laniakea's cosmic landscape. To truly visualize this, one must zoom out far beyond individual stars, even beyond galaxies, until the galaxies themselves appear as mere dots scattered across a map. At this scale, Laniakea becomes visible, appearing as a vast gravitational basin where galaxies flow like rivers towards a center, pulled by the great attractor. a mysterious region whose powerful pull shapes the movement of our entire supercluster. What makes Laniakea truly outstanding is not only its colossal size, but also its remarkable internal coherence. Despite the entire universe steadily expanding, all galaxies that are part of this grand supercluster maintain their unity and move in sync. Astronomers have diligently mapped these cosmic flows, meticulously tracking the velocities of thousands of galaxies, and as a result, have discovered a striking pattern. They all converge toward the same specific region of cosmic space. This can be compared to how the universe itself is an endless ocean, and Laniakea is one of its mighty, unstoppable tides, carrying everything in a unified direction. For Andromeda, this profound connection places its entire rich history within an even broader and more comprehensive context. Its majestic halo, the numerous collisions it has experienced, and its inevitable future merger with the Milky Way, all unfold within the wider, dominant framework of Laniakea. Just as a large city shapes the lives of its many citizens, a supercluster exerts a formative influence on the existence of its constituent galaxies, guiding their growth and determining their interactions over billions of years of cosmic time. And yet, even Laniakea is not the ultimate, final boundary of all that exists. Beyond it stretch other superclusters, like other gravitational continents, artfully strung along the enormous, invisible cosmic web. Each possesses a scale beyond human comprehension, and yet, each represents only one delicate thread in the magnificent tapestry that spans the entire observable universe. To contemplate this is to come face to face with the true, immense scale of existence itself. However vast Andromeda may seem, it represents only one voice in the grand chorus of countless galaxies that sing in the cosmic darkness. From Earth, we can see virtually none of this directly. The night sky shows the naked eye only a handful of galaxies, and even through powerful telescopes, we perceive them as isolated, disparate points of light. However, the truth is that we are all connected to an empire of unimaginable size, to a realm where Andromeda is both enormous and incredibly small. The Laniakea supercluster serves as a reminder that every galaxy, without exception, is part of something far greater than itself. And when we look at Andromeda, faintly shimmering in the boundless darkness of space, we see not just a neighbor across the void. We see a full citizen of immense celestial space, one of countless threads in the boundless, majestic fabric of the entire cosmos. By measuring and studying Andromeda, we simultaneously learn a great deal about our own galaxy. Its stars, its halo, its mysterious dark matter, all reflect the characteristics of the Milky Way, offering us a unique reflection that we cannot see from within our own galactic home. The Milky Way is enormous, but from within it, our view is extremely limited. We see only narrow glimpses, a shimmering band of starlight crossing the night sky, scattered star clusters, and dense curtains of cosmic dust that obscure its core from our view. It's like trying to understand an entire forest while standing among its trees, without seeing the big picture. Andromeda, however, provides us with something entirely different, an outside perspective. It is the closest large spiral galaxy to us, and it is tilted at a perfectly opportune angle, allowing us to clearly see its spiral arms, its central bulge, and its vast halo. In its light, we find a kind of mirror of what our own galaxy must look like to outside observers. By studying Andromeda's complex structure, astronomers gain insight into what to expect in the Milky Way as well. Its trillion stars, organized into characteristic spiral arms, resemble the presumed arrangement of stars in our own galaxy. Its dense central bulge, glowing with the golden light of ancient stars, reflects the one hidden behind dust in our heavens. Even its dark matter halo, detected through analysis of star movements on its outskirts, teaches us how to map the invisible structure surrounding the Milky Way. Every new discovery about Andromeda deepens our understanding of our own home. This galaxy also vividly demonstrates how spiral galaxies grow and change. Its stellar streams, the remnants of galaxies it absorbed millions of years ago, show us how merger processes shape a galaxy's halo. Its active star-forming regions demonstrate how gas flows along the spiral arms, condensing into new star clusters. Its population of old stars tells us how bursts of active creation alternate with long, quiet periods. Each of these valuable lessons applies not only to Andromeda, but to us as well. They help explain why the Milky Way looks the way it does and how it will evolve in the distant future. Perhaps most importantly, Andromeda serves as a powerful reminder of our galaxy's inevitable fate. Its slow but steady approach, meticulously measured over decades, confirms that we are on a collision course. By observing Andromeda's movement, astronomers can predict how this merger will occur, what new galaxy will result from this cosmic dance, and how this process will forever change the night sky we see. In a sense, Andromeda is both our teacher and our future, a companion whose path is inextricably linked with our own. Studying the Andromeda Nebula has also significantly expanded the boundaries of human technology. From the very first telescopic observations made centuries ago to the high-precision measurements carried out by the Hubble Space Telescope and the Gaia mission, our instruments have invariably improved, following escalating curiosity. Each new enhancement revealed previously unseen details, be it faint halos, subtle movements, or hidden stellar populations. In Andromeda, science finds both a serious challenge and a worthy reward. But beyond data collection, there is a deeper perspective. Contemplating Andromeda is not merely looking at another galaxy. It is a powerful reminder of the grand scale of the universe. Our entire world, our Sun, our Milky Way, these are just tiny particles of a much vaster whole. And yet, by intently studying this cosmic neighbor, we begin to grasp not only our current position, but also what we are a part of. Andromeda teaches us that true knowledge comes not only from introspection, but also from looking outward, from the ability to see ourselves reflected in the light of other worlds, even if they are millions of light years away. Andromeda is not just a galaxy, it is an overarching reminder of scale, of boundless time, of the cosmic destiny that awaits us all. To know its size is to glimpse our future, to realize our true place, and to comprehend the infinite space that encompasses all existence. For most of human history, this faint smudge in the night sky remained an insoluble mystery. Was it a cloud within the Milky Way, a cluster of stars too distant to distinguish individually, or something else entirely? Now we know the truth. It is another majestic galaxy, larger than our own, vast beyond human imagination. To measure Andromeda is to confront numbers so colossal that they almost lose their familiar meaning. Trillions of stars, millions of light years across, a halo that gradually fades into invisibility. These are not just figures to be mechanically memorized, but rather sensations to be felt. They serve as a reminder of the immensity of the cosmos. Andromeda also teaches us a valuable lesson in patience. Its light takes 2.5 million years to reach us. Every time we look at it, we see not its current state, but its distant past. It is a portrait painted long before humanity appeared on Earth. Thus, Andromeda is both near and incredibly far. We know that it will one day merge with the Milky Way. Nevertheless, this grand event will occur billions of years in the future. Galaxies move at their own pace, much slower than any human measure, teaching us humility in the face of cosmic time. Its history is also our history. The Milky Way and Andromeda are partners in a cosmic dance that has already begun, drawn to each other by the relentless force of gravity. Their merger is inevitable, their destinies inextricably intertwined. To look at Andromeda is to gaze into the future of the night sky, anticipating what our galaxy will become. The stars we see there today may one day become our neighbors, their light mingling with ours in a new, shared cosmic home. But perhaps the greatest perspective Andromeda offers is that of belonging. We often tend to think of ourselves as small, fragile, isolated, a single species on a single planet orbiting an ordinary star. And yet here, across the boundless void, lies a galaxy of unimaginable size, connected to us not only by gravity, but by a true kinship. Its stars are like ours. Its planets may be home to life like ours. Its future is inextricably linked with ours. In the end, Andromeda is not the other. It is an integral part of the same universe that lovingly nurtures us all. To measure it, to name it, to imagine its true size is to see our own place in the boundless cosmos more clearly. We are not the center of the universe, but neither are we lost in it. We are active participants in something immense, ancient, and inexpressibly beautiful. Andromeda, faintly glowing in the night sky, serves as a vivid reminder of this fundamental truth. It is more than just a galaxy, it is a mirror of destiny, a beacon of scale, a symbol of profound connection. And when we allow its light to penetrate our minds, we see not only the universe beyond, but also the infinite within ourselves. As we conclude our journey today, let us pause and remember all that we have seen. Andromeda, our closest great neighbor, is not just a faint smudge in the sky. It is a galaxy over 200,000 light-years wide, containing almost 1 trillion stars, countless worlds, and mysteries that extend into the invisible realms of dark matter and the cosmic web. We have traveled through its spiral arms, past its dust lanes and stellar nurseries, into its very heart, where a supermassive black hole anchors its luminous core. We have traced the streams of stars that tell of its cannibalistic past, and we have wandered in its halo, among its dwarf satellites and the faint filaments that connect it to the Virgo supercluster and the vast Laniakea beyond. In Andromeda, we have seen not just another galaxy, but a reflection of our own, a mirror by which we understand the Milky Way, and a prophecy of the future we will one day share. And above all, we have seen perspective. To know Andromeda is to know the true scale of the universe. Humanity must inevitably grasp the true scale of the universe. It dares to measure the passage of time, counting it in billions of years, and to estimate boundless cosmic expanses stretching for millions of light years. And despite this astonishing boundlessness, humanity is capable of maintaining a wondrous sense of invisible connection that subtly unites each of us, transcending boundless cosmic voids. This realization invariably reminds us that even amidst the astounding infinitude of universal expanses, everyone represents an integral component of something grand and all-encompassing, something brightly shining, something truly infinite in its majesty. When a person immerses themselves in a state of peaceful tranquility, they should carefully cherish in their heart a deep sense of appreciation for the invaluable opportunity to exist and feel alive in this immense and delightful universe, whose beauty strikes the imagination. Special gratitude should be expressed for the unique gift of consciousness, which grants the ability to gaze outward, beyond earthly existence, and experience genuine wonder at the majesty of the cosmos. And also for the undeniable reminder that each of us is not merely an observer, but an active participant in a grand story, whose chapters are skillfully woven into the shimmering tapestry of the stars.